Hello everyone and welcome to our today's class. It is our fourth lesson on the topic heat transfer. So let me start by giving you the quote of the day, which states that if you don't define what success means to you, you will by default be forced to use the definition of others. And also remember this, that we become successful by what we get, but we become happy by what we give. So we will discuss this quote at the end of our class. So today we are looking at radiation. Remember, we looked at the three modes of heat transfer. We did say that we have conduction, we have convection, and lastly we have what we are calling what? Radiation. So today we are going to discuss radiation as a mode of heat transfer. So to understand radiation, we need first to start by definitions. We need to know what we mean by this term what? Radiation. Remember, conduction involved heat transfer through solids. Convection involved heat transfer through fluids, which is partly liquids and partly gases. Now, when we talk about radiation, in most cases, radiation will be heat transfer through gases, or what we call, sometimes we call it in a vacuum. Now, what is radiation? So radiation, this is the transfer of heat from one place to another by means of electromagnetic waves. The transfer of heat from one point to another by means of electromagnetic waves. Now, what are electromagnetic waves? Electromagnetic waves can actually flow within a vacuum. That is, they do not require what we call a material medium, such as maybe air. So we also need to define what we mean by thermal radiation. What we mean by thermal radiation. So thermal, as we said earlier, means heat. Then radiation, we have said, is the transfer of heat from one point to another by means of electromagnetic waves. So thermal radiation simply means this is the heat transfer through vacuum. The transfer of heat through vacuum is what we are calling thermal radiation. So it is important to know that radiation does not require a material medium. Remember, a vacuum is an empty space. That is a place without air. A place without air. So we are saying that radiation is the transfer of heat from one point to another by means of electromagnetic waves, whereas thermal radiation is the transfer of heat through vacuum. Then we also need to look at the nature of radiation. The nature of radiation, that is, what does it constitute, or what is it made up of? Now, the nature of radiation is that when a material absorbs radiation, it actually that radiation can actually cause what we call a heating effect. So when electromagnetic waves are absorbed, or when electromagnetic radiations are absorbed by a body, it can cause a heating effect. Now, the amount of the radiation absorbed, or the amount of heat radiation or electromagnetic radiation absorbed, depends on the nature of the surface which is absorbing that particular radiations. So in that regard, we look at an experiment here which can be used to show that indeed electromagnetic radiations or heat radiation can cause what we call a heating effect. So in this experiment, you need what we call a hand length or a magnifying glass. We also need light and heat from the sun. So you just take the hand length. You also need a piece of paper. So what you do, you just take that hand length or the magnifying glass and place it on the region where the rays of the sun can actually hit it. So you arrange the apparatus as shown in this diagram. Then you focus the rays of the sun and heat from the sun on a paper and actually observe what happens. So when this experiment is carried out, after some time, it is observed that the paper gets burned at the point where the rays are actually concentrated. Now remember, this lens, we use a lens, what we call a converging length. To converge means to focus things at a particular point. That is, you take maybe, like for this case, we have rays coming from different directions from the sun, but they are being focused to one point. This ray is being focused this way, this other ray is being focused this way, this other ray is being focused centrally. So as you can see here, all the rays are being focused at one point. So when the electromagnetic radiations, that is from the sun, are focused at one point, they cause a heating effect. So here it is observed that the paper actually gets burned at the point where the rays are being focused. So this proves or ascertains that heat radiation or electromagnetic radiation can cause a heating effect. Now, we've just said that the amount of radiation that is absorbed by the material depends on the nature of the material. So that means we have different types of what? Surfaces or materials which can absorb the radiation. So we have two categories of surfaces which can absorb radiation. So we have what we call the dull or the black surfaces and what we call the shiny or polished what? Surfaces. Now, how do dull or black surfaces absorb heat or radiation as compared to the shiny or polished surfaces? Now, dull or black materials, they are good absorbers of heat radiation. They are good absorbers of heat radiation. At the same time, they are also good emitters of the radiation. So it is important to know that materials which are good absorbers of radiations will also be good emitters. To emit is to release or to take away. So materials which are good absorbers of radiations will also be good emitters of radiation. So dull or black surfaces are good absorbers of radiations, and they are also good emitters of radiations. So on the other hand, or on contrary, shiny or polished surfaces, they are poor absorbers of heat radiations. They are poor absorbers of heat radiations. At the same time, shiny or polished surfaces, they are also poor emitters of radiation. So we are saying that good emitters of radiations, that is the good absorbers of radiations, that is the dull or black surfaces, will also be good emitters of radiations. On contrary, shiny or polished surfaces, which are poor absorbers of radiations, they will also be poor emitters of what? Radiations. Poor emitters of radiations. So we look at various applications of the dull and black surfaces. In fact, that explains why when someone actually takes water in two similar basins but being painted differently, that is, if you take water on the sun with in a black basin and in a white or a shiny basin, we are taking conditions to be constant. That is, assuming the same amount of heat gets to that water in the two basins, which are similar, the same amount of water. The basins are similar, the only difference is they are painting, the color. So it is observed that the water in the black basin actually gets warmer faster than the water in the shiny basin. So the reason is because black or dull surfaces or the dull basin absorbs heat faster than what? Shiny or polished what? Surfaces. So you also need to know that shiny or polished surfaces, which are poor emitters of radiations, they are very good reflectors of radiation. So you need to know that poor emitters of radiations, which is the shiny or polished surfaces, they are very good reflectors of radiations. Next, we look at an experiment which is involving comparison, that is to compare absorption of radiant heat by different surfaces. So in this experiment, the apparatus required are, we need a Bunsen burner or any other relevant source of heat. We also need maybe two surfaces, that is the one being dull or the black surface. Then we also need a polished surface. We also need wax here and also wax here. Then we need some two cocks, one here and one also here. So the apparatus are arranged as shown in this diagram in such a way that the wax is used to glue or to hold the cocks onto the surfaces. So the cock is actually attached on the dull surface with wax, also the same coke is attached on the shiny or polished surface by wax. Then a source of heat is placed midway or at the midpoint. That is, the distance from the source of heat up to the dull surface is the same as the distance from the source of heat up to the shiny surfaces. So you ensure that these distances are the same, so that the amount of heat getting to the shiny surface and the dull surface is exactly the same. So after the apparatus have been arranged in this manner, a Bunsen burner or any source of heat is actually put on, such that there is a flame here, or it produces some heat which get to those surfaces. So an observation is made maybe after something like 10 or maybe 20 minutes on the position of the cokes. So after the Bunsen burner is put on for around 20 minutes, it is observed that the coke attached on the dull surface actually falls off first before the coke on the shiny or the polished surface. In fact, in some cases, actually the coke on the polished surface will not fall off. Now the question is, why does the coke on the polished on the dull surface or the black surface fall off first? So here is the reason. So remember, we are saying that dull or black surfaces, they are good absorbers of heat radiation. So it means that the dull surface under the same conditions will absorb more heat radiation from the Bunsen burner than the heat that will be absorbed by the polished surface. Why? Because dull surfaces are good absorbers of what? Heat radiation. So because dull surfaces are good absorbers of heat radiation, the heat absorbed will be used to melt the wax. Now whenever the wax actually melts, it means it breaks the contact between the coke and the dull surface, and that's why the coke falls off after some little time. However, polished surfaces are poor absorbers of what? Heat radiation. Or they are, remember we said that poor absorbers of heat radiations, they are the best reflectors of radiations. So it means whenever heat from the Bunsen burner actually gets to the polished surface, it is reflected away. So if it is reflected away, it means there is no heat that will be used to melt this wax. That's why the coke remains attached to the polished surface, because the heat that will otherwise be used to melt the wax so that the coke falls off, it is actually reflected away. And at the same time, polished surface or the shiny surface is a poor absorber of heat. So we are simply saying that the coke attached to the dull surface falls off first, because dull surfaces are good absorbers of heat, so the heat is used to melt the wax, therefore breaking the contact between the coke and the dull surface. Therefore the coke falls off first. Then we are saying that the polished surface is a poor absorber of heat, or is a good reflector of heat, therefore it does not absorb heat. Therefore, because there is no heat to melt the wax, it means that this coke will remain intact or in contact with the polished surface, therefore does not fall off. Therefore it does not fall off. We also look at another experiment which is similar to the other one, although we are using different apparatus. So this is also to compare the absorption of radiant heat by different surfaces. So in this experiment we need two thermometers. So this is our thermometer, which we are calling thermometer B, that is TB. Then we also have another thermometer here, which we are calling thermometer S, that is TS. We also need two similar cans. We have or tins, tin A here, then we also have another tin B here. Then we initially fill the tins with water to exactly the same level. Remember, we are keeping similar conditions. So you fill the water up to this level, you also fill this can with water up to this level. So the only difference, then we of course cock it at the top, we also cock it at the top. The only difference here is actually the nature of the material used to make the tin. So one tin surface is made by a dull surface or the black surface, then the other one is made with a polished or a shiny surface. Then we place a source of heat midway or at the midpoint or at the center, to mean the distance from the heater up to tin A is the same as the distance from the heater up to tin B. So when we initially record the initial temperatures of thermometer B, that is TB. We also record the initial temperatures of thermometer S. So we expect the initial temperatures of thermometer B and that of thermometer TS to be the same. Why? Because we are taking similar water at similar initial temperatures of similar quantity or amounts, and we are using similar tins. The only difference is their painting. One is painted silvery or shiny or polished, while the other one is painted what? Black. So the source of heat is actually switched on, and an observation is made about the rise in temperature. So after the source of heat is put on, maybe for something like 20 minutes, it is observed that the thermometer TB, that is the thermometer in tin A, records a higher temperature as compared to the temperature recorded by the thermometer in tin B, that is the TS. Now the question is, why does the thermometer in tin A or the thermometer B record a higher temperature than in tin S, yet they are dipped in the same amount of water? So the reason is simple. Dull surfaces are good absorbers of what? Heat radiation. But polished surfaces are poor absorbers of what? Heat radiation. At the same time, they are good reflectors of heat radiation. So because the dull or the black surfaces are good absorbers of heat radiation, it means the dull surface will absorb a lot of heat from the heater actually. So the heat absorbed by the dull surface is used to warm or heat the water. So when the water is warmed, it means its temperature will actually rise. So that's why the thermometer TB records a higher temperature. Conversely, the polished surface is a poor absorber of heat, and it is also a good reflector of heat. So it means when the heat from the heater actually gets to tin B, it is reflected away by the polished surface, which is also a poor absorber of the same heat. So being a poor absorber of heat, it means it will only absorb a very small amount of heat, or even it may fail to absorb any heat. So when heat is not absorbed, it means the water in tin B will not be heated, because there is no heat to heat it actually, because a polished surface reflects away that heat instead of absorbing it. So because there is no heat to warm the water, that's why the temperature of thermometer TS remains lower as compared to the temperature of the thermometer TB. The temperature of thermometer TB. We also look at applications of thermal expansion. Now, where do we apply thermal expansion in real life situations? So our first application is in kettles, cooking pans and iron boxes. Now, how is thermal expansion applied in what? Kettles, cooking pans and what? Iron boxes. So kettles, cooking pans and iron boxes, they have polished surfaces to reduce on heat losses through thermal what? Radiation. So if you observe your kettle very well, it is made of a silvery surface, or it is highly polished. It is usually very shiny. I'm sure you've never met a kettle which is actually painted black, unless the one who made it does not understand the reasons behind what is doing. But if you are a good physicist or a good physics student, kettles should be made with shiny surfaces. Why? Because shiny surfaces are good reflectors of heat and they are poor absorbers of heat. So it means if you place tea or any other substance, for example water, in that kettle, the temperature of the water will remain relatively high. Why? Because heat loss from the substance in the kettle is minimized because of the shiny surface, which prevents heat loss through radiation. Cooking pans, in a similar way. Cooking pans, these are the ones that are used to cover the cooking, for example, what we call the sufurias. The tops, they are usually made of shiny materials. In most cases, it is usually white. This is so that whenever heat tries to escape from the food or the boiling water, it is reflected back by the cooking pans, which are shiny, thereby preventing heat loss through radiation. So this enables the food or even the boiling water to actually get boiled faster. Then also iron boxes, their layers have shiny surfaces to prevent heat loss through radiation. So you can be asked to explain how kettles, cooking pans and iron boxes why they are made of what? Silvery materials, or or why they are polished. They have polished surfaces. So this is to prevent heat loss through radiation. Then petrol tanks also apply thermal radiation. So petrol tanks are painted. They are painted silvery bright to reflect away as much heat as possible. So if you look at the tankers carrying the petrol, they are usually painted white or silvery bright. So this is to prevent heat loss. This is to prevent heat absorption. So that it can, remember we said that shiny materials are good reflectors of heat. So petrol tanks are made with shiny surfaces to reflect away the heat. So remember, this is petrol, and petrol is highly flammable. So if you absorb a lot of heat, the petrol is likely to there is likely to be a fire outbreak. So to prevent that, we usually paint the petrol tanks silvery. In most cases it is painted white, so that the heat from the sun is reflected away. Therefore there is no heat absorption by radiation. So this reduces a possible fire outbreak. Then houses in hot areas and in cold areas. Now how do they apply thermal expansion? Now houses in the houses in hot areas have their walls and roofs painted with bright colors to reflect away heat, while those in cold regions have walls and roofs painted with dull colors. So remember, we are saying that houses in hot areas, they have their walls and roofs painted with bright colors. Remember, bright colors are shiny colors which actually reflect away heat. So if a house is in a hot region, that means you need to reduce the temperature of the house. So you don't need to absorb more heat, because the house will be more hot and it will be inappropriate for survival of human beings. So to prevent more heat absorption, we usually paint their walls and even the roofs with very shiny colors or with very bright colors, so that most of the heat from the environment is reflected away. Conversely, houses in cold areas, now here, because they are cold areas, it means we need more heat within the house. So houses in cold areas have walls and roofs painted with dull colors. Remember, dull or black colors, they are good absorbers of what? Heat. So if the houses are painted with dull colors, in most cases it is usually black, it means the house is able, the walls are able to absorb more heat, so that the house is kept at relatively some higher temperature, while the outside area is actually cold. So houses are painted with dull colors in cold regions to absorb heat, because dull colors or black colors are good absorbers of what? Heat radiation. Then the further application of thermal expansion is in solar concentrators, the solar concentrators. So in solar concentrators, electromagnetic waves in form of radiant heat are reflected to a common point, which is the focus, by a concave reflector. Remember, concave reflectors will always focus rays at a particular point. So the temperature at this point can be sufficiently high to even boil the water. So in solar concentrators, so it means solar means heat from the sun, then concentrators, to concentrate is to focus something at a particular point. So you can see here we have radiant heat from the sun, then we have our concave reflecting surface here, which is actually converging. So you see there is an incident ray here, it hits the surface, then is being converged here. We have another ray here, hits the surface, converged there. We have other rays, they hit the surface, then they are being converged here. So at this point where all the rays are focused, this point is at a very high temperatures, because the whole of heat has been focused here. So at this point, the temperature of this particular point can be used to even boil the water. So solar concentrators apply the same principle, and that heat can be used in even what? So our fifth application is in what we call greenhouse effect, or the heat trap. Now how does a greenhouse effect work or apply thermal expansion? So a greenhouse has a glass roof through which radiant heat energy from the sun passes. So this heat is absorbed by objects in the house, that is the plants, which then emits radiations of low energy, that is of low electromagnetic wavelength, that cannot penetrate the glass. So the cumulative effect is that the temperature of the house increases substantially. So greenhouses are used in providing appropriate conditions for plants in cold what? Regions, in cold regions. So the heat, actually the radiant heat gets into the greenhouse, it is absorbed by the plants, then the plants and the soil emit radiations of low energy which cannot penetrate out of the greenhouse. So it means that heat is trapped within the greenhouse. So when it is trapped there, it means the temperature of the greenhouse will actually be high. And remember, there are some plants, for example tomatoes, which require some relatively higher temperature, which are there are sufficient conditions for growth. So when the temperatures are kept relatively high, some plants will actually survive there. So in cold regions, you will find most greenhouses to maintain a higher temperatures, which is appropriate for thriving of some of the plants. Then we also apply thermal expansion in solar heaters. Now solar heaters, it uses the solar energy to heat the water. So a solar heater consists of a coiled blackened copper wire on a blackened insulating surface. Then radiant heat from the sun passes through the glass and is absorbed by what? The blackened copper pipes that contain water, which is heated up. Now remember that copper pipes and copper collectors are used because copper is a good conductor of what? Heat. So they are, however, painted black to increase the absorbing what? Power. Then another application of thermal expansion, that is our last application, is on what we call the thermos flask, or what sometimes we call a vacuum flask. So what is a thermos flask or a vacuum flask? So a thermos flask is designed to keep its content at a fairly constant temperature by minimizing heat transfer, of heat between the contents of the flask and the surrounding environment. So here are some of the parts of a thermal flask. So it has what we call the rubber pads, it has a stopper, it has some silvery wall case, then we have a rubber ring. It also has what we call the double walls. So the flask is made of a high quality glass blown in such a way that it is double walled. So these are what we are calling the double walls. We have one wall here, then another wall, so we have the double wall there. So the air between the double wall or the walls is pumped out to create a vacuum. So air is pumped out of this wall, that is the space within this wall. It usually has air, so we pump out that air to create a vacuum, or a place without air to create a vacuum. So this vacuum is an excellent what? Insulator, minimizing heat transfer by both conduction and convection. So the air removed prevents actually heat transfer by conduction and convection. Remember, if there was air, there could be heat transfer through convection or what? Currents, or even by conduction, So the purpose of the vacuum is to, or the double walls, is that they have a vacuum in between them that prevents heat loss by both conduction and convection. Then heat transfer by radiation, which might be relatively large, is reduced by a layer of silver coating on the inside of the surface, so that each wall is a poor emitter and poor absorber of what? Heat. So we have what we are calling here the silvered wall casing. So silver is a very shiny material. So remember, we said that shiny materials are good reflectors of heat and poor absorbers of what? Heat. So it means if you have maybe tea or any other relevant liquid which you want to maintain the temperature, the silvered wall, so the inside, this inside wall of the double glass is painted silvery or shiny. So this shiny material or the silver materials reflects away heat back to the tea, so that there is no heat loss to the environment. So because it reflects back the heat, so this prevents heat loss by what? Radiation. It prevents heat loss by radiation. Now you also remember that we also have what we are calling a stopper here. So the stopper actually prevents heat loss by evaporation. So it is cocked well. The stopper is cocked well at the top to prevent heat loss by evaporation, because remember the liquid within the conduct within this the double walls could actually within the flask could actually evaporate. So to prevent heat loss by evaporation, we use a well cocked stopper. Then we also have what we are calling the soft pads. These are the rubber pads, this one and this one here. Now what is their role? So the role of the rubber pads is to hold the glass flask firmly in the case, to hold this glass flask firmly within that case, so that it is not shaking from time to time. Then the metal or the plastic cover is necessary as a protection for the glass envelope. We usually have a glass, this cover here. It is usually made of an insulator, in most cases plastic. So its main function is actually to cover the double wall so that they do not easily break. So the common questions here is that you can be asked to state how heat loss is minimized in a flask. So you simply say a flask has double walls which have a vacuum within them that prevents heat loss by conduction and convection. Then a glass flask has silver, its inside wall is silvered to prevent heat loss by radiation. Then it has a stopper that prevents heat loss by what? Heat loss by evaporation. So we've come to the end of our class today, but we need to discuss the quote of our day. So actually the quote of the day was about focusing on your own progress. So I think the quote of the day simply states that if you don't define what success means to you, you will by default be forced to use the definition of others. So that means that you need to define what success means according to you in every sphere of your life. You need to define what success means to you spiritually, what being successful means to you financially, what being successful means to you emotionally. If you don't define what success means to you, you will by default be forced to use the definition of others. So that means you will be doing things to compete with others. You see someone purchasing a vehicle, you also want to purchase a vehicle. No, focus on your own progress. So define what success means to you in every sphere of what? Life. And remember this, that we become successful by what we get, but we become happy by what we give. So the choice is yours. Do you want to be successful or be happy? For me, I choose being what? Happy. Because when you are happy, automatically the other things will come. But for you to be happy, what brings happiness is what you give out. And remember, what you give out is not just money. What we give out, there are three main things you can give someone. You can give someone your time, your wealth, or your energy. And when these three things, that is time, wealth, and energy, are used to make a positive impact or difference in someone's life, then that legacy can never be taken away. So don't just rush to be successful for the sake of being successful. After all, when it comes time for that is when you die, what remains? If you had vehicles, if you had big houses, if you had money, if you had whichever possessions, you cannot be go with those things. The only thing that remains is the impact that you made in someone's life. So be careful about the impact that you are making in the lives of those around you. Don't be selfish to just think about yourself. Think of also the others, because when the people around you are okay, automatically you'll also be okay. So it is very important, because it will also give you what we call the peace of mind. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.